Alright, welcome back everyone. So look at 2.1 lesson notes. So we're going to learn details of tangent ratio. Alright, so today's objective, this section is objective. Develop the tangent ratio and relate it to the angle of inclination of in a line segment. Alright everyone, using A in the diagram for all three triangles, find the tangent ratio. Angle A. So we're going to use angle A to solve the problem. Here, angle A. And we're going to find the tangent ratio of ABC first. Okay? Okay, before we start, we have to label each side. If we are using this angle A, BC is the opposite. And AB, so this is the longest side. This is hypotenuse. And this adjacent, right? Okay, so let's do SOHCAHTOA. TOA. Tangent is opposite over adjacent. Oh, I actually wrote it here. Okay, opposite over adjacent. Okay, opposite. So look at the opposite. So 1 unit is 1 centimeter, everyone. Then we have 2 centimeter. Opposite is 2 centimeter. So 2 over opposite over adjacent. Adjacent is 1, 2, 3 centimeter. So 2 over 3. Tangent A is 2 over 3. Okay, so we're going to use the same angle A, but we're going to use a different triangle, different right triangle, which is ADE. Okay, everyone, before we do this, I want you to guess. Do you think we will be getting a same number or different number? The same ratio or different ratio? So let's try this. Again, everyone, this is the opposite. Opposite over adjacent here. So opposite is 1, 2, 3, 4. Adjacent is 1, 2, 3, 4, 5, 6. It's 4 over 6. Okay, everyone, what do you think? Is 2 over 3 same as 4 over 6? Are they the same fractions? Let's reduce 4 over 6. What do you get? 2 over 3. Are they the same fraction? Yes, they are. They are the same fraction. They're the same ratio. Okay, let's try the last one, AFG. So what do you think? Can you guess? Do you think we get the same ratio or different ratio? Okay, let's try it. Opposite over adjacent. Opposite is 1, 2, 3, 4, 5, 6. Opposite is 6. And adjacent, 3, 6, 9. Adjacent is 9. Is this the same ratio? Yes. If we reduce it, we get 2 over 3. All those ratios are the same ratio because we're using the same angle. So we are using the same angle, tangent A. So question 1, are we getting the same tangent ratio for the 3 triangle? Yes. The size of the triangle is not really important. What's important is the size of the angle measure. So this can be like 30 degree or 40 degree, I don't know. It looks like 30 something degree. So tangent A, tangent 30 something is 2 over 3, 2 over 3, 2 over 3. right? So it doesn't matter how big the right triangle is, as long as the angle measure is the same, as long as you use the same angle, you get the same ratio. Okay, so question 2. How can we find the angle measure of A? So we don't know the angle measure of A. Can we use the tangent ratio to find it? Yes, we can. Alright, everyone, then tangent, we don't know what the angle measure is. We don't know how many degrees this is. So tangent angle measure should be 2/3. So how do you change 2/3 to a decimal? So if you put 2 divided by 3 in your calculator, you get 0.6 repeating, right? Okay, now we're going to find angle measure in degree. So we're going to find this angle that has the tangent ratio 0.6 repeating, right? Get out your calculator, and I want you to find sine, cosine, tangent button. So I have my sine, cosine, tangent button right here. And make sure your mode should be not radian, it should be degree mode, right? Okay, then get out your calculator, and I want you to hit tangent button. And if you look at this angle, so what do you think? So can you guess the angle measure? It looks like 30 something degree. So I'm going to try 30 degree first. So in your calculator, I want you to hit 30 degree. That is 0.57. It's not 0.6 repeating. And it should be a bit bigger than 30 degree. 33. Let's try 33. Oh, that is 0.64. Then let's try 35. Oh, 0.70. That's too big. Then let's try 34. 0.6745, but it's not very accurate. So we know the angle measure is about like 33 to here, 33 degree to 34 degree. But this is not an accurate answer. So we want to know the accurate answer. How would we be able to find the accurate answer? In this case, we use inverse tangent. So look at this. So we know tangent something is 0.6 repeating, which is 2/3. To find this, we use inverse tangent button. Look at the calculator again. So do you see this little like blue inverse tangent sign on my calculator? Your calculator probably have inverse tangent. Your calculator should have inverse tangent button here. So tangent button, and right above it, its inverse tangent is written. To do that, what I'm going to do is I'm going to hit second. Here, I'm going to hit second. So in your calculator, you guys may have shift button or second button, and I'm going to hit tangent. So now I have a different function. So this is just a regular tangent function, and this is inverse tangent function. Okay, inverse tangent. So inverse means like opposite. You're going to do that like in opposite way. So what we are going to do is you should put angle measured in tangent, regular tangent function. But in inverse tangent function, you should put the ratio because it's opposite. So let's do 2 divided by 3, 2 over 3. Then I get 33.69. It's a lot more accurate. Okay, 33.69. Okay, so here, so we guess that it is in between 33 to 34. So using inverse tangent button, we found this is 33.69 degree. So using an inverse tangent button, we can find the angle measure a lot more accurate. Make sense, everyone? So here, what you do is find second button, second, or maybe alpha or shift in your calculator, and then tangent button, and then you have to put ratio. Tangent button, this is actually tangent. If you hit second or shift, that is actually inverse tangent. And you're going to enter the ratio. Then you will be able to find the angle measure. Okay, let's move on. Example 1. Find the tangent 45 for each triangle. Okay, we're going to find the tangent 45. Everyone, tangent. Tangent is SOHCAHTOA, opposite over adjacent, right? So T is O over A. And before we find the ratio, always, the first step is always find the name of the side. So we have 45 degree here. So this is opposite. So let's name all the side: opposite, adjacent. Opposite, adjacent. Opposite, adjacent. All right. Tangent 45 from the first one. That is 1.6 over 1.6. Opposite over adjacent. Second one. 2.7 over 2.7. Third one. 3.8 over 3.8. So whether doesn't matter. It doesn't really matter. The size of the triangle does not really matter. If you find opposite over adjacent, it becomes, what is this? 1, right? So you divide 1.6 by 1.6, becomes 1. So tangent 45 is always, always 1. Like tangent 33.69 is always 2 over 3. Tangent 45 is always 1. Make sense, everyone? Okay, let's move on. For the right triangle below, find the indicated value. Okay. If you look at this, tangent A. This is using the angle A. So we're going to think each side relative to A, based on A. So this is opposite. I want you to label it opposite, hypotenuse, and adjacent. And we're doing TOA, SOHCAHTOA, opposite over adjacent. Tangent A is opposite over adjacent, 5 over 12. Tangent B is, we have to change it, then we have to change the angle. So we are not using A anymore, we are using B. Now, this is opposite, this is hypotenuse, and this is adjacent. Tangent B is opposite over adjacent, so 12 over 5. So we've found tangent A and tangent B ratio. And now we have to find the angle measure. Again, everyone, remember, tangent, angle, tangent, angle becomes the ratio. Okay? So remember, do you remember how you actually found it? So you use inverse tangent button, right? So inverse tangent, A is tangent inverse 5/12. So we're going to find the inverse tangent button. So inverse tangent button is over here. Second, inverse tangent 5/12 bracket. So that is 22.619. So let's round it. Round it to the second decimal place. That is 22.62. So the angle is 22.62. The next one, tangent. Again, we want to find the angle. So if you want to find the angle, you use inverse tangent. So inverse tangent 12/5. That is 67.38. Okay, so this is how you find angle measures using a calculator. So remember, I'm just going to write it down here. To find angle, use inverse tangent. To find ratio, use just regular tangent. Okay? So remember this. Okay, number 3. For the right triangle below, find the tangent ratio. So now we're going to find the tangent ratio. In that case, we use regular tangent. Tangent 20. So we're going to do tangent 45. Tangent 6. So using your calculator, get out your calculator, and I want you to try tangent 20, tangent 45, and tangent 60. So 0.36391, 1.732. So 0.36 and 1.72. Okay, so this is how you find the ratio using angle measure. Okay, as you see, as the angle measure increases, the ratio also increases, right? Next, find each angle measure to the nearest degree for each tangent ratio. Everyone, we're finding angle measure. In that case, would you use regular tangent or inverse tangent? We use inverse tangent. Inverse tangent 0.57. Inverse tangent 6.9. Okay, everyone, go ahead, everyone. I want you to use your calculator to find the answer for those 3 questions. Go ahead. Alright, everyone, I assume that you guys paused the video and tried those 3 questions, and I'm gonna go over those 3 questions. Okay, have you guys tried those 3 questions? Here's the answer for those 3 questions. So you use inverse tangent 1.78, you get 61 if you round it, And use inverse tangent 0.57, you get 30 degree if you round that. And C is 82 degree if you round that. Okay, let's move to the next question. Alright, example 4. 10 feet ladder leans against the side of the building with its base 4 feet from the wall. What angle to the nearest degree does the ladder make with the ground? We want to find this angle. Okay, we want to find this angle. Let's say this is a theta. Okay, everyone. We know this is 4 feet and this is 10 feet. And we're going to use a trigonometry ratio to find the answer. Okay, we are only using tangent ratio. So we're going to find the tangent ratio of this. Okay, so if this is a theta, so this is opposite, this is adjacent, and this is hypotenuse. Is that right, everyone? But we know hypotenuse and adjacent, but we don't know the opposite. But we need opposite because tangent uses opposite and adjacent. How would you find the length from here to here? So we learned this. We actually solved this kind of problem in your review package. How would you do that? So we're going to use Pythagoras. So we're going to use Pythagorean theorem. Is that right, everyone? So we know a squared plus b squared is c squared. So a squared is 4 squared. Let's say opposite is x. X squared should be 10 squared. Then 16 plus x squared is 100. Okay, then let's subtract 16 from both sides. Then x squared is 84. Then x is square root of 84. Okay, now we know the opposite. The opposite is square root of 84. Alright? Okay, then tangent theta is opposite over adjacent. Square root of 84 over 4. Opposite over adjacent. And now we want to know the angle. To find the angle, would you use inverse tangent or regular tangent? We are using the inverse tangent. Square root of 84 over 4. Okay, so let's hit this into your calculator. Inverse and square root of 84 divided by 4, and that is 66.42. So theta is 66.42. So it's asking nearest degree, so we say that is 66. Theta is 66 degree. Alright everyone, that is it for today. We learned 2 sections today. So this is not an easy concept, everyone. I want you to actually review it again. Again, everyone, I'm uploading all the videos online. So if you don't understand, I want you to go back and watch the video again. Alright, everyone? So thanks for watching. So I want you to go back to your chapter outline, and I want you to start doing your worksheet. Okay? And if you don't have the worksheet, so if you start your class online, you probably don't have this worksheet, right? So if you don't have the worksheet, you can just simply print it out from Teams. I uploaded everything on Teams already. Okay, thank you everyone.